everybody. It's Friday, October 16th. We just finished up another great week of school, another great week of great participation, positive attitudes. I loved it. So keep that going. And so, again, I want to recap kind of the highlights of what we did this week. So this week, again, we focused on that idea of proportionality. And really what we did is we transitioned from using proportions to now looking at this idea of a constant of proportionality and what that looks like in an equation. So at the end of last week, we came up with this concept of a constant of proportionality. And we said how in the book they're going to designate the letter K to represent this constant of proportionality. And we defined it as y over x. But we kind of left it there. And at the beginning of this week, we picked right up with this. And we defined this a little bit more. And we said this y is going to represent my dependent variable. And instantly many students said, oh yeah, I remember the dependent variable in science class and looking at different labs and where you would identify these variables. And instantly they remember, well then if that's the dependent, this is my independent variable. And we talked about how this is going to be something that we are going to really focus in on this week. So we began this week kind of reiterating this equation, and we then kind of used some math to look at this equation a little bit differently. So what we did is, at the beginning of the week, is I asked you to isolate the y or solve for y. And so students then, many of them came up with a proportion, and they used this idea of means extremes to solve for y. So if I do y times 1, I get y. And if I do k times x, I get kx. And we looked at this equation, and I told them how important this equation is going to be, not only for this year, but for the next few years of their math career. And we're going to be using this a lot. And so we broke this equation down, and we looked at the different parts. And we said, okay, there is my constant. I can see my COP, my constant of proportionality, which in a moment we're going to look at an example of, that'll give you a better idea of what that is again. And we can see our independent variable, and we can see our dependent variable. Again, these variables we are going to start identifying with every scenario, and we'll identify with an example that I'm going to show you in a moment here. So we looked at this equation, and now it was time to use this equation. So the first thing we did is we just looked in the book at some basic problems where they would give us what y equals. They would say y equals 3, and they would say k equals 7. And so now you were asked to plug these into this equation and just practice using this equation so that we're ready for some real life scenarios that we're going to get to again in a moment. So we just plugged it in. So if it says y equals 3, I'm going to plug that in for y. If it says k is 7, I'm going to plug that in for k. And now I'm going to, obviously, the only variable that is unknown is my x. So I'm going to solve for my x. So in this case, to get x by itself, I want to get rid of that times 7. So I'm going to do the opposite. So I'm going to divide by 7. And really what we're practicing right now are some very basic algebraic skills that many students learned, or all students learned last year in 6th grade, as this is really a 6th grade concept, solving a one-step algebraic equation. So now I get x equals, and if you're wondering how did I get x by itself, well, 7 divided by 7 gives me 1. And 1 times x, there's my x. And x equals, yeah, we can just leave our answer as a fraction. Okay, that is actually okay. That's a number, 3/7. So again, we're slowly creeping into just getting some practice on how to use this equation. So now, from there, we spent the remaining 2 days on Wednesday and Thursday really looking at some real scenarios. So this is, I just picked one problem out from a worksheet that we looked at on Wednesday and Thursday. And so this problem said the Hidden Valley Cross Country Track Team is participating in a 3-day walkathon to raise money for their favorite charity. They are asking each donor to pledge $18 for every 6 miles they walk. So the first thing I asked was, okay, in this scenario, what are the two variables? What are the quantities that are going to be changing? And we identified, well, first of all, we have this money that they're going to earn. That's going to change. And we have this distance, the miles that they are going to walk. That's going to change. And so the next question is, okay, well, which one of these variables depend on the other? And immediately many students said, well, the amount of money they're going to make depends on the number of miles they walk. So my constant, in this case, my constant, or K, is going to be, and remember we said it's y over x, my dependent over independent, is going to be that amount of money that they make over the number of miles, and I'll just use M, that they walk. So in letter A, it says how much money will the team raise if it walks 150 miles during the walkathon? So the first thing we're going to do is we are going to identify and put in an actual value in for K. What is, in this story, the actual K? What is the value of that constant, that y over x? So in this case, since we said it was the money was the dependent and the miles were my independent, we could write it as $18 over 6 miles, which some students instantly said, well, I could actually reduce that, right? I could simplify that fraction to, really, that's $3 per 1 mile. And many times the COP is going to be written as a unit rate. So we all of a sudden remembered, oh, we started making these connections. All the way back to the beginning of the year, we started with ratios and rates, and that evolved to unit rates. And then we got to this idea of a constant. And here we are, we're going full circle. My constant is a unit rate. So again, we're making those connections. So now, as we go to A, we said the question is, how much money will the team raise if it walks 150 miles during the walkathon? So I didn't give any directions on how to solve this because I wanted to see how students were going to solve it. And I kind of assumed and expected this. Many students resorted back to what we've been working on, which makes sense. So they went back to a proportion. So many students set up their proportion as something like this. So $3 over 1 mile, and we are looking for how much are they going to make if they walk 150 miles. So here would be the proportion that students would set up. And again, this is where we've been. We've already tested on this, your ability to solve a proportion, and many students use that idea of scaling up since they saw they could easily do that. 1 goes into 150, multiply by 150. We call that scaling up by 150. And we're going to do that same thing on the top to get an answer of $450. So that's kind of where we've been, but now we want to bring back that equation, that idea of, okay, I can solve with a proportion, but how can I incorporate this y equals kx equation? This was our focus this week. So again, I said before the y was my dependent variable. And notice up here, we said the dependent variable was the amount of money. So instead of y, I could leave it as y, but I want to be a little more specific. I'm going to use a dollar sign. That's going to represent the amount of money. Equals, here's my k. Remember we said the k was the constant of proportionality. So if I look at my constant, remember we said it could be $18 over 6 miles, or a simplified version of that, $3 over 1. Well, what is 3 divided by 1? Well, that's just 3. So I don't need the over 1. I can just put it as 3. And the x, remember, represented the number of miles. That was my independent variable. So now if I come back to this same problem, and this is what I ask students to do a second time around, I ask them to now, could you incorporate the equation? Could you solve the same problem using that equation? And so now this is what they did. They would plug in for the miles now, 150. So I would simply have the equation, the amount of money they're going to earn equals 3 times 150. And they got obviously the same answer, $450. So this is where we left off for the week. We're gonna pick up a little bit on this on Monday. We're gonna review a little bit of this on Monday. Again, focusing on that idea of using this equation to solve these problems, kind of transitioning out of a proportion and focusing more on using the equation. But next week is going to be more about how can I identify that COP in a graph. The graph is going to be our main focus this next week. So can't wait to see you on Monday. Have a great weekend and come ready to learn on Monday. See ya.